In this video, we're going to look at a specific type of equation called a proportion, and we're going to analyze how to solve it. Because the methods that we use can be slightly different, there is a shortcut, although we still want to apply the same rules for solving linear equations, which is whatever you do to one side, you must always do to the other. And I'll show you why that's the case in what we're doing here. All right. As we look at solving proportions, you can see I've got the exact same problem here because there's often two ways to go about solving a proportion. And either way is fine. Some students see one way easier than the other. I'm going to start off with something that you're probably familiar with called cross multiplication. All right, cross multiplication is when you take the numerator of one fraction and you multiply it by the denominator of the other. All right, so in this case, 3 times x right along that line. I'm going to multiply those and then get the result. 3 times x is 3x, and that's going to give me one side of my equation. On the other side, I'm going to take the numerator of the other fraction, multiply it by the denominator of the first fraction here, and get that result. 6 times 11 is 66. Now, why are we allowed to do that? You don't have to show what I'm about to put, but this is why. Anytime in mathematics, we can always multiply by the denominator to get rid of it. If I multiply both this side by x, it'll cancel out with this x, and therefore I'd have to do that to the other side. I'd have to multiply by x there. All right? That's where I get this 3x from. It's multiplying by x on both sides. One side it cancels, the other side doesn't. All right? In the same way, I can also multiply by 11 on both sides, canceling those out. Multiplying by 11 there, giving me that 6 times 11. So that's really what's happening, but we don't show all of that. All right? We typically just do the two lines across the middle to make a nice little x to make our cross multiplication here. All right, so that's what I'm showing you right there. And from there, we just solve it as we normally would. All right, now I have all my x's on one side. I have all of my constants on the other. So I'm going to just isolate x by dividing by its coefficient. Divide both sides by 3. And in this case, x is equal to 22. All right, that's the value of this equation that will make it true. All right, we'll prove that in the second version. Another way to solve proportions is to understand that they're equivalent fractions. Equivalent fractions means that you get from one fraction to another by multiplying by a giant 1. If you can see what was multiplied by, you can get there quicker. So take a look at the two numbers I know in the numerator. I know 3 and I know 6. All right, those are the two that I know. How can I get from 3 to 6? What would I be able to multiply it by? Well, 3 times 2 is 6. And so in order to make this equivalent, whatever I did to the 3, I'd have to also do to this 11. Well, 11 times 2 is 22. And that's where you can see the exact same answer that we got over here. Now, if both ways work, and the second way definitely looks easier, why would we not use that all the time? Well, sometimes you get some crazy fractions like this. I mean, take a look. X minus 4 over x. I can't see what to multiply x by to get to 3 or vice versa, and I definitely don't know what you multiply x minus 4 by to get to 7. So at this point, I'm only left with my option of cross multiplication. In this case, I'll do 7 times x. I'll come across here 7 times x, and I'll get that result, which is easy, 7x. All right. The other side, not so easy, but let's do it anyway. We got to remember this is the group x minus 4. And if I come across to multiply with 3, I'm really looking at 3 times x minus 4. And I've got to distribute that. All right? When I do that, I find that I'll get 3x minus 12. All right? Now I have an equation that has x's on both sides, and so I'll start by moving one of my x's to the other side. Subtract 3x from each side, giving me 4x equals negative 12. Don't lose your negative. And then we can divide by 4 on both sides to find out the value of x, which in this case is negative 3. All right? That means that negative 3 is the value of this proportion, the value of x that will make this proportion true. And I can test that. Negative 3 minus 4 over negative 3 equals 7/3. And is that true? Well, negative 3 minus 4 is negative 7 over negative 3. All right? And they look similar, but we got these negatives. Keep in mind, negative divided by a negative is a positive, so these two will actually cancel each other out to become a positive 7/3, which does indeed equal 7/3, making our proportion true.